All right, so good afternoon, also from Austria. And first of all, thank you very much for this kind invitation. We are very privileged to be with you, and we are still, although we are already 3 days into the country now, we are still overwhelmed by the legendary Omani hospitality. And I will make personally sure that our people back home in Austria really get envious about how well we were treated here. So thanks for all this. And I think we Europeans sometimes have to learn from you on this as well, I believe. Now, what I would like to share with you is something very different, something very much else, with a story which seems to be like coming from the future. In terms of that, what I'm going to talk about now might seem like a little bit like science fiction to many of us, because it has not happened yet. But bear in mind that when you listen to my next presentation parts, that by the standards of our grandfathers, we are living in a science fiction world. If you would explain to your grandfather what the world looked like, what your office looks like, how you communicate with each other, how you collaborate with people from the other side of the planet, that would have been perceived as science fiction 50 years ago. And I promise you, I don't know how many of you already have grandchildren, you will have a challenge explaining to your grandchildren that there was a time when a computer, a telephone, and a television were 3 different devices. Yeah? And so keep that in mind. So first of all, just to give you a little bit of a context, you see my CV, I always when I read this, who's that guy? Basically, what I'm doing is I'm leading a team of 200 people back in Austria, where we're preparing for what can be designated as the grandest journey of our generation in a way. I think that's something which can really make it into history books. But of course, we are just a small group. There are many, many more, even much bigger groups, which are working on those topics. So I'm also an analog astronaut, together with Joao Lozada. He's also representing the analog astronaut corps here. And we all do all kinds of serious science, and some of this is combined with fun. Yes, these are parabolic flights where you have some zero gravity and do interesting research experiments. Now, I think the relevant part is I will promise there will only be a very few slides with so much text on it. The most will be like a narrative. We are a research organization since 1992. We do hardware development, spacesuit simulators, rovers. We fly stratospheric balloons. We operate a ground station for satellites. We have a scientific focus on planetary surface operations. That it means, how do you manage all the instruments, the people, the workflows in the field to both work as safe as possible and as efficient as possible? I think that's a trait we certainly share with PDO as well, safe and efficient as possible. Then we also optimize remote science support. Like, the people in the field or on Mars will be focused on operating the equipment, acquiring data. They won't have the time to sit back and interpret the data they get from their instruments. For that, we have Earth. So the question is, how can we establish a situational awareness in the remote science support teams on Earth so that they have the feeling as geologists they are almost there. Yeah? And that's the reason why we try to get our hands dirty. So what we do here is reflect first on Mars itself. For those of you who are not that familiar with the topic, and it's of course a niche topic as well, this is an actual image from Mars taken by the Mars Science Lab Curiosity. It's the heaviest equipment that has ever landed on Mars, about 1 ton of a nuclear-powered rover. This is a picture about 1 week old. And it gives us a perspective on a world which has a lot of stories to tell. When you've ever been with a field geologist out in the open, it's an amazing situation that they seem to have a conversation with the rocks. I don't know if you've ever had that feeling. I always have it when I walk with a geologist in the field. And it's like, when I look at the picture like this and you see all those beautiful layerings here, for me that's almost like books in a page, and every page tells a different story. Like, the story here is that we know Mars is now a very dry and cold world. We're looking into something at minus 70 degrees Celsius average temperature, 1/3 of the Earth's gravitational force, about 1% of the Earth's atmospheric pressure. So it's very unlivable at this moment. But we also know it was not like this all the time. Mars and Earth started at the same time 4.6 billion years ago when our solar system evolved. Now, we have good reason to believe Mars had liquid water, even in the form of oceans on its surface, up to 3 kilometers deep and that to a time up to 3.5 billion years in the past. You could go deep sea diving on Mars a long time ago. Now, we even see the shorelines of this. But now it's a cold, dry world. So even understanding why this climate changed so much is an important thing for us, also for Earth as well. And we always talk about, yeah, Mars is far away. It is far away, 380 million kilometers. We have about more than 10 minutes of time delay between the communication, even if you travel with the speed of light with a signal. So when you have a crew on Mars and they are in trouble, and they radio back to their mission control center here in Muscat and say, Muscat, we have a problem. It takes more than 20 minutes until the response comes, aha, yeah, and what exactly? So small talk gets a little bit boring if you're on Mars. You have to change the way how you communicate. But Mars is not far away when compared, of course, to other astronomical dimensions. And sometimes we are lucky that we're even able to touch Mars. And you will have a chance now to almost touch Mars. And that'll be with something I'm trusting you a lot with this now, but this little friend here, it's in this box. I have a small meteorite. Meteorites are something not uncommon, of course, but if you're very, very lucky, you sometimes find a meteorite that is not from the asteroid belt, but from Mars. We know this because of the isotope signature. It's a chemical fingerprint, so to say, which tells us where it comes from. And so if I open that, it's actually a fragment of a larger meteorite that was found in Morocco. I will pass it through, and I hope that everybody gets a chance to see it. If you like, can take pictures, of course. Please don't take it out. I know what it looks like. It's, if you see such a rock on the road, it's nothing to us. We don't even bow down to pick it up, of course. Yeah? But if you know the story, that this little guy has traveled for 10 million years in open space before landing in Morocco and then being found by Bedouins who brought it then to researchers, that rock has quite a story to tell. So whenever I talk to school children about this, and we just had the chance of talking to 420 high school students and elementary school students in the Grand Mosque in Muscat, which is a fantastic event. I loved it. We always tell them, well, you are the generation to make the journey. I firmly believe the very first human to walk on Mars is already born and might be going just to elementary school in New York or Beijing or in Muscat. Who knows? We don't even know if it's going to be a man or a woman, for instance. So whenever I tell them to consider that, that's a very strong driver in them. And hopefully, if we have a good timing, maybe after like half an hour, I can get it back, and we'll do another thing with this rock. But in the meantime, enjoy watching at a piece of rock which is not from this world. It's an alien piece. So we are creating an invasion from Earth, so to say, in a way that we have a number of orbiters around the planet Mars. We have several, actually 2 active rovers on the surface. So whenever you read a science fiction novel about any invasion of Martians to Earth, in fact, it's the other way around. And so when we compile all this data and we try to synthesize our knowledge about Mars, we realize there's one big thing, and that is it was wetter, it was warmer, had a denser atmosphere, it was much more hospitable to life. Now, we don't know if life ever started there. Maybe there's even a chance that some rocks from Earth traveled to Mars via very shallow meteorite impacts which sputter off the material, and a tiny little fraction makes it there. We don't know that yet, if life could have transferred through this way. But I think the stunning fact is that we are the first generation which has the technological and scientific means to maybe answer the question if we are alone in the universe. And if somebody asks, oh, why do you go to Mars? It's so expensive and risky and whatever. And we'll talk about the numbers a little bit later. I always say I wouldn't personally, because besides being extremely curious and wanting to explore, I couldn't stand the question of my grandchildren one day if I sit in front of the TV and watch the first actual Mars landing, and my grandchildren would have asked me, what took you so long? Why didn't you go earlier? The answers of all life in the universe would have been there. So what took you so long? Why did you hesitate? And I don't want that question. That's the reason why we must go. One more reason why we must go. So remember, Mars was warmer and wetter. It lost the magnetic field, lost the atmosphere, and the temperatures dropped down, and so it became a very dry place nowadays. So we want to go there and look for life. That's one of the major questions. And that can be answered by establishing a geological context, by establishing the framework of how we can do this technologically. So we have a framework program in place. It's called the Polaris program, which has been executed for 10 years now. It's coming to an end, and it's being replaced by the MID program. That's the reason why the mission is called MID, and 18 stands for 2018. And MID, by the way, I don't know if you've heard about the Austrian composer Wolfgang Amadeus Mozart. Amadi is the second name, and that's the reason. It's not an acronym, it's actually an Austrian reference. So we are developing workflows for field activities. We have the spacesuits in place, the robots. We have a fully fledged mission support center, and these entire missions are being science-driven, basically. We have also a technology developed which is not unique but rare, let's put it this way. There are 4 teams worldwide that are working on spacesuits for Mars. We are the only European team. It's basically a spacecraft to wear. It keeps you alive. It's also a living computer, so to say. It's a wearable computer. It weighs more than 45 kilograms. If you're not yet well trained, it takes you more than 3 hours to put it on for the first time. But on the other hand, it keeps you alive. You can eat and drink and go to the toilet inside and so on. So it has a sensor network. It has voice command inside. The capability, we have gesture control, head-up display, and so on. But just to give you a little side note on what people are sometimes getting excited about technology-wise, is also few things you can study in the laboratory. For many things, you have to go out into the field. Like the geologists say, the one who's seen the most rock is the best geologist. And the same thing applies for us. We want to go out and break things. Yes, you heard me right. The more mistakes we make here, the less mistakes we make on Mars. And so one little thing, just as a side note here, when you're in a spacesuit and it's heavy, it's really getting warm inside, you have a thermal control system, but nevertheless you might start to sweat. Now when we humans start to sweat, we have a reflex that our nose starts to itch. And during the day, you just do like this, and you don't even realize it. Yeah? In the spacesuit, you cannot scratch your nose, obviously. Yeah? And believe me, sneezing inside a spacesuit is a mess. You don't want that. Yeah? And for that reason, we have here a piece of foam, basically, RFD, razzle-frazzle device, where I can simply make like this, and you don't sneeze inside. Yeah? So it's little things that makes your life comfortable as an astronaut. Still, it's hard work. So spacewalk is a physically exhausting activity. And whenever a spacesuited astronaut is outside in the field, we have an entire team monitoring them. So we have people in the field, we have safeties there. We're transmitting, when Joao will be in the spacesuit, he will also have an ECG, which is then transmitting its data via satellite to the mission support center where medical doctors sit, which get a signal which is 10 minutes old because he's on Mars. You cannot see a signal in real time. So they have to predict and have a deal. Okay, there might be a problem coming. Let's act early. Yeah? So the way how we perceive our safety structures are very different from real-time operations, of course. So it's optimized for being also a biological barrier because you don't want to contaminate the rock samples which you're investigating for life. You have typically 4 to 8 hours of field operations. We could do more from the suit side, but at one end, the human has to give in. It's just too exhaustive at one point or the other. And it produces a lot of data, and so we have a very delicate network system in place which helps us to transfer the data that are necessary back to Earth. This is an image from our latest class, 2015. We have, the reason I'm showing this picture is because you see a little bit the internationality. We have colleagues from, Joao is from Portugal, Carmen Köhler from Germany, Kartik Kumar from the Netherlands, Inigo Munoz Elorza from Spain, and Stefan Dobrovolny from Austria. So we call ourselves the Austrian Space Forum, but that's more of a historical connotation. The working language is, of course, English in a way. We do a lot of laboratory work. We expose the spacesuit to strange environments, like we go to cryo chambers at minus 110 degrees Celsius. So if you ever feel chilly, that's expert level chilly. Because we're in the evening on Mars, you can have minus 100 degrees Celsius, so that's quite a challenge. Also, what we realize, there are other dangers on Mars, like compared to Earth. For instance, you know, dust devils, yeah? But dust devils on Earth are mostly harmless. They have a little bit of dust and maybe a little bit of electrostatic discharges. However, on Mars, because of the lower gravity and the faster winds, dust devils on Mars can come like 2, 3, 4 kilometers high and even higher. And so the electrostatic discharges can be really strong and you really want to avoid them. But maybe you cannot avoid them because the dust devil is chasing the astronaut. And so we exposed the spacesuit, for instance, also to lightning discharges from 6 million volts onto the spacesuit to see if the spacesuit is really reliable. And that's one thing where we realize you have to trust the engineers. Because I presume most of you will be engineers, have some engineering background here in the room, that although many times we sit at the office and compile Excel sheets, I don't know whatsoever, we sometimes tend to forget that sometimes other people's health and lives depend on our numbers. And so this is a special type of responsibility we have to instill on our engineers in terms of safety thinking so that we can say, okay, it's safe enough to expose a human to 6 million volts without any damage. And I'm happy to report, I'm the guy inside, that it went well, the experiment, obviously. We also have remote science support developed over many years, which do the science training, which support the development of the hardware and the procedures, who do the near real-time analysis. Never forget that all those missions, be it real or simulated, always take place in 2 locations, Earth and Mars, which means on Mars, and that will be Oman, will be Mars for us in February. We have the experiments which send the data to the base station. We have a 10-minute communication delay, and then we have the mission support center in Austria, again, which is supported by a number of subsidiary control centers. So we have, for instance, a rover which is controlled from from North America, which is channeled through basically the mission support center. They authorize the usage, and then they telecommand the rover in the desert, so to say. And all the way back, the same thing again. Just to give you a few impressions of this mission support center. This is part of the flight control team crew. These are highly trained specialists, which are usually coming from the engineering and scientific background or human factors, which are supported by flight planning team, by ground support, by information technologies, remote science support, and of course the national teams. Just a few impressions of what our control room looks like. Not as fancy as ISS or International Space Station control rooms, but don't forget, in the end, even ISS control room is a room full of computers and highly trained people. Nothing more, nothing less. So we are really, we are a little bit beyond the garage workshop type of exploration, but we are not operational yet. So we still have a long way to go. That's a typical day in our work, so we know precisely who is doing what. We have the mission plan already many months in advance. The mission plan is already fixed for February, so I can tell you that on the 8th of February, around 10 o'clock Austrian time, we will land on Mars, well, on Oman. Huh? And then for the rest of the day, we know what we're going to do. Just as a brief overview of what type of research we're doing, first of all, we are very careful in selecting the best sites. This is an example, not from Oman. We don't have so many pictures which we're showing yet. So this is from a previous mission, 2013. The picture on the left was taken on the 15th of February, 2013, just after a dust storm. So even the sky color is the real one. And the picture on the right side was taken just 1 week afterwards on Mount Sharp with the MSL Curiosity rover. So those 2 pictures are 1 week apart, but they're also 2 worlds apart. Huh? And and we saw similar locations in Oman as well, where if it wouldn't be for the sky color, you couldn't tell if it's Mars or Earth unless you're a specialist, so to say. We do. This will be our 13th expedition, 12th or 13th, depending on the counting method. This is in southern Spain, for instance, in Rio Tinto. This is one of the very few deserts, very small deserts, I have to say, in Europe. Where we were driving with the Eurobot ground prototype. It's a car, the most expensive car I was ever allowed to drive, 1.4 million euros, 10 years of development time, and the maximum speed, like this. It's not built for speed, of course, but it's an intelligent car. You can also drive it from the space station. Alexander Gerst, our German astronaut, 2 years ago, made his driving license on that from space. So I saw a certificate where he got the symbolic driving license for that. We also go subsurface, so that's one commonality we share with Oman as well. Oman has magnificent karstic caves. We also have a lot of karstic caves in Austria. The difference is because of our lower temperatures, we have a lot of ice in some of them. And yes, we believe that there are also ice resources on Mars subsurface in caves. And caves are very interesting from the astrobiology point of view because they are protected environments. You don't have any meteorite impacts, you don't have radiation there. From the climate and the temperature variations, it's fairly stable. You have water there. So if life ever arose on Mars, let's say 4 billion years ago, and then the environmental parameters were deteriorating, getting colder, getting more dry, and so on, then maybe life would have withdrawn to those caves, residuals where life might still persist until today. We just don't know that. And so we call them, I love this expression, it's a technical term we have in astrobiology. We call those ecological niches the swan sea ecologies, like the swans who are singing in our culture in a way. So where the last songs of life are sung. Isn't that a poetic description? Huh? So that's an example of one of the caves we were using. We also went to high altitudes. So we had a mission 2 years ago in the Austrian Alps on a glacier, because glaciers also exist on Mars as well. So we were at more than 2,800 meters. So we set the world record for the highest Mars simulation during this experiment. And you see, for instance, an experiment which comes from our Hungarian colleagues. The Puli rover doesn't even have wheels. It has wags. It's a mixture between wheels and legs. So it walks with little legs through the rocks, so to say. It's a very versatile instrument. Just to give you a few examples of other experiments, this is a few of a typical setup for the operations station. This is the logical representation of the landing ship on Mars, so they are allowed to communicate in real time. We have 2 analog astronauts which are getting ready for the extravehicular activity, aka the spacewalk. Rovers, more rovers. A couple of years ago, there was this debate going on if we should send robots or humans to Mars. You know, robots are more sturdy, they don't have unions, you can use them all the time. But on the other hand, humans are more creative, so what's the balance? And then nowadays we say we don't have that choice of sending either humans or robots. We say send them both, because they all have their distinctive advantages. Like on Earth, we also cooperate with robots without really noticing it. If you have an automatic car washing facility, that's also a robot. Yeah? Maybe you don't think of it as a robot. But what you see here, when you have 2 rovers, the Magma rover which is controlled from Torun in Poland, is if you don't manage the control centers properly, you risk the first simulated traffic accident on Mars, because they're going to roll over each other. I think Magma would win. The wheels are much bigger, but they don't want to play monster truck on Mars. We also look into contingency situations. So what happens when something goes wrong and you sprain an ankle, for instance, you break a toe or so, and you cannot walk back to the base station anymore. Now, when we Austrians get stuck in the Alpine mountains at night, when we don't make it back to the valley again, we usually have with us a small emergency tent, a small bivouac. And we said, well, can we take this proud Austrian tradition of losing our way and getting stuck in the mountains and make this space age-wise? And so we got together with our colleagues from the Technical University of Vienna and said, well, we make a shelter which is inflatable. So it's a system about the size of a wheel. We put it on the rover, on a quad bike, for instance. And when we are in trouble, you basically unzip the structure. You relieve some locks there with carbon fiber parts which are the tension, a little bit of hydraulics, and it goes like flip, 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 and you have this here. And then you have a pressurization. You don't see there's a compressor here which uses air to inflate the inflatable parts here. And depending on how you navigate with the hydraulics, you can inflate a chair or a table or a sofa. And what you like, you close it, you zip it, you seal it, and then you can take off the helmet and survive the night there until the rescue team comes. We do virtual reality a lot. I presume that also a lot of you are working with virtual reality to have some situation awareness as well. Just an idea that you have some idea of how we think is, for instance, this Vera system. Actually, that's from Italy, from our partners in Bergamo, where you have an Oculus Rift, the 3D goggles. I think they're very common now. And you have an exoskeleton which allows you to mimic the limitations of the spacesuit. and you are in an omnidirectional treadmill with a very slippery surface. You're guarded here with a ring, so you can walk, but you don't move. And this movement is being recorded by a 3D camera outside, which translates your movement into moving in the virtual world. And if you have a digital elevation model, you can walk virtually on Mars. And best of all, you are in a climbing harness, and that takes away 2/3 of your weight, which means also the gravity feels like being on Mars. It's quite fascinating to try it out. If you do little hops or so, it's really nice. And you can have you see your own hands in the gloves. You can go into a virtual laboratory, work in a virtual glove box, for instance, and train things there, or actually predict when there might be troubles in the field. This looks like our analog astronaut Stefan Toporolny is brushing his teeth. No, he's not cleaning his teeth. We thought, what happens if you break a tooth on Mars? That's inconvenient, might be trouble, could be infection. You don't want to have that. And so what he does, we said, well, let's assume he broke his tooth for what reason ever. So what he's doing there, he's taking a 3D scanner and scanning the cavity. The data are sent to Earth, to the dentists and the medical specialists. They create a 3D model of the cavity and a replacement part, send back the data, and then we have a medical-grade dental printer, 3D printer on Mars, and we print the replacement tooth. And the reason why I'm showing this particular experiment, these are typical examples of where we have a high potential for spin-offs. Imagine remote communities where there is no dentist, but maybe somebody with a 3D printer. Maybe that's a solution for our children to get a replacement tooth in 20 years from now. Who knows? So it's a mission which is science-driven, but of course has many more dimensions to it as well. We have a lot of international visibility. We have more than 20 countries that are participating, and we are really making sure that, that everybody is aware of what kind of magnificent deserts we have. It's something which might seem very noble and a very familiar thing to you because it's your country, but to us it's something very special. Like for you, maybe snow on the mountains might be special. For us it's normal. For us it's your deserts which are so special. We also saw there's a high potential for catalyzing interest in science, technology, education, mathematics subjects called STEM outreach, and also a catalyst for engineers within the Omani R&D community to maybe consider careers in engineering and maybe also in the space field as well. That's a place we are close to Marmul, so that's the next major city actually is Salalah, I would say. So a little bit off the grid on your premises, so to say. So thank you for that you're allowed to be there. And you probably know the area anyway. So, but the thing is that when I look at this picture, I already see a few things which remind me of Mars, where I can say, okay, here's where we can test rovers, here's where we can dig down, here's where we use georadar to look for old wadis and look for ancient fluvial structures, for instance. So we're going not as deep as you might be going, but at least a shallow subsurface will be investigated here as well. So one of the questions is sometimes why we do this. And again, as I said, there are some scientific reasons, there are political reasons as well, there are economic reasons for going to Mars. For me, it's something else. This is a picture of the monastery library of St. Florian near Linz in Upper Austria. That's where I was born. So when I was a little child, I was allowed to walk in. I don't know if you have ever had the chance of being the first one in a huge library and opening the door, and there are tens of thousands of books waiting for you with all those magical stories. And the moment when you open the door and this new world opens up to you with things you haven't known before, that's a magical moment. And that's exactly what we feel as scientists when we ask questions to nature. It's like a book. It's just the letters of nature might look a little bit different than our book pages, but there are still stories which are waiting for us. So to paraphrase Carl Sagan here, I can promise you whoever goes to Mars, I can promise you that something incredible out there is waiting there to be discovered. So instead of, well, saying Mars is too dangerous, too difficult, and so on, you might know this movie poster from The Martian a couple of years ago was out. Very good book, actually. Instead of bringing it home, we always say, take us there. So yes, there are people seriously thinking about that already. You probably heard about Elon Musk. You heard about SpaceX, maybe a company which was non-existent 15 years ago, basically, and now is already one of the largest launch providers for the United States and other customers. They're already thinking about a mission to Mars. This is the concept model for the Red Dragon, a slightly earlier model of a small crew cabin to land on Mars. So again, this might look like a science fiction poster. In fact, it might be something where in 10 years we say, well, that's of course it was a logical thing to do. Arthur C. Clarke says all the big projects in the world, no matter throughout history when you look, always had 3 stages. And maybe if you look from this from the PDO perspective, I think you find some similarity. When you try to make a big project, first reaction is it cannot be done. Second reaction is, it could be done, but it's not really worthwhile doing it, too expensive, too risky, whatsoever. Third stage, I've always said it's a good idea. Yeah? And so we are somewhere between stage 2 and 3 in a way. So don't tell me the sky's the limit when there are footprints on the moon. And before I close out, no, actually we'll do the close out after. May I ask where the meteorite is right now? It's almost through? Very well. Okay, thank you. You can continue. Is that I would like to share with you a little bit the essence of exploration by presenting you pictures from both Mars and our simulations as well. So maybe if we can make it a little bit darker or as dark as possible in the room, and you can lower down the blinds. If we have something like a movie theater atmosphere would be great, because I've bombarded you now with lots of numbers and figures, and I think you've deserved now some eye candy. And we put on a lot of pictures from people that are working with us. I deliberately do this because we always have to be aware a few people are the front people, like in a large company, but it's the company in itself which makes these magical things. It's always about the people, and that's the reason why I put in a lot of images from our colleagues. So before we come to this, we see sunsets on both Earth and Mars. These are actual pictures of the real sunsets taken with a camera which has the same view like a human eye. And so we just ask you, I invite you to lean back, relax, and enjoy pictures of our greatest journey yet to come. can turn down the volume, music down. You've seen that there is a lot of young faces in those pictures, fairly young students sometimes. And so we think because the next generation of humans is actually the next one which is going to take the journey. So we are just the shipbuilders. Yeah? Everybody knows Christopher Columbus, but nobody knows the shipbuilders. Yeah? But they're also important, of course. Yeah? It's a team sport. And so it's a particular pleasure that we have lots of young students involved as well, including also an experiment from Oman. So we have a geoacoustics experiment with two young female students from an elementary school. And is Dr. Al-Hosni here? Ah, there is. Nice to meet you. He is basically supervising the participation of those young ladies here as well. And because we said that it's on one side the scientific interest, of course, which we have in those kinds of experiments, but at least as important to stimulate more young people. And it's only two young students, but I'm sure they will have an experience where they talk a long time about to their peers and their ecosystems from a social point of view. So we're very much loving that. And so when we have those, and maybe that's something Dr. Holsen can relay them when next time he meets them, I have a request when those two are working with us, especially if one of them should turn out to be the first human to walk on Mars, the first person to walk on Mars, they have just the right age for that, that if they do so, that one of those two little ladies, when they land on Mars, rocket goes down, ladder folds out, make the first step, say the first sentence, which will go down into the history books, of course. Cameras are switched off. That they take this little box out of the spacesuit, open it, take with the thick gloves the little rock out there, put it back on the ground, and say, "You're home again." Thank you.